What we're looking at here is a Sumerian tablet that actually shows the tree of life, flanked by divine beings. You can see here the Anunnaki on each side.
There is a terrifying collision between a 4,000-year-old cuneiform tablet and modern EEG data. The ancient Sumerians didn't describe death as an off switch. They mapped it as a staged journey through 7 gates where awareness persists. In 2013, peer-reviewed Neuroscience recorded a real, close to 30-second gamma-wave surge in dying brains, a final burst of consciousness that rhymes disturbingly with that Old Babylonian text. This isn't about a 7-minute myth. It's about 7 specific gates and a measured physiological event that shouldn't exist. So what did that tablet actually claim happens the moment the body dies? The tablet they pulled from the dust of Nippur. The tablet doesn't describe a moment. It describes a map. The text, known as Inanna's Descent to the Netherworld and catalogued as ETCSL 1.4.1 by the Electronic Text Corpus of Sumerian Literature at Oxford, lays out a precise, agonizingly detailed sequence of events. Here's the physical reality. This isn't a rumor. We have the clay. Researchers have reconstructed over 400 lines from multiple fragments excavated from Nippur, with pieces from dating to the Old Babylonian period around 1900 to 1600 BCE. Nippur was the religious heart of Sumer, the city of the god Enlil. So finding fragments there places this text at the center of ancient scholarship. That's the era when cuneiform writing was standardized across Mesopotamia, roughly 3,600 years ago. The 7 in the title comes from the 7 gates. The narrative builds around a single soul figure passing through 7 thresholds, and at each gate, she surrenders an item she can't take back. Watch the sequence the tablet records. First gate, the turban, symbol of divine authority, gone. Second gate, a string of small lapis beads, stripped. Third gate, twin egg-shaped beads, gone. Fourth gate, a pectoral bearing the phrase, "Come man, come," a charm for protection. The text implies this phrase was meant to compel the gatekeeper, yet it fails. The ornament is taken. Fifth gate, a golden ring. Sixth gate, a measuring rod and line, tools that let her define boundaries and measure the world. The gatekeeper claims them. Now, she's stripped of her power to shape reality. Seventh gate, the pala robe, a garment of power and vitality. She gives it up. The tablet is brutally clear. The moment that the robe leaves her, she is turned into a corpse. Scholars rely on the ETCSL standard, though Datura Wolkstein and Samuel Noah Kramer's 1983 translation in Inanna, Queen of Heaven and Earth also shapes the modern understanding. Both versions lock onto the 7 gates and the stripping sequence. This is the core, and here's the critical distinction. Nothing in this text mentions 7 minutes. The 7 come entirely from the gates and the items. Any connection to a 7-minute timeline is a modern overlay, likely imported from later interpretations of brain activity. The tablet resists temporal projection. The structure is spatial and material, not temporal. The gates exist in a landscape, not a clock. This is the oldest written map of dying we have. It treats death not as an instant off switch, but as a staged passage where identity dissolves piece by piece. Other ancient texts focus on rituals for the living, but this tablet functions as a manual for the dead, mapping the mechanics of the transition itself. You lose your authority, your adornments, your protection, your power to measure the world, and finally your vitality until only a corpse remains. If a story survives 4,000 years on broken clay, is that because it's a good tale, or because it's describing something every one of us eventually walks into? But the 7 gates are only the setting. What the Sumerians wrote next is the part that should raise the hair on your neck, because they didn't describe the body simply shutting down. They described something leaving the body while it's still awake, still you. So what did the tablet say survives the moment your heart stops? The part of you, the Sumerians said, stays awake. The tablet says the conscious self doesn't vanish. it detaches. The Mesopotamians gave this surviving entity a specific name, Gidim in Sumerian, or Atemu in Akkadian. This is basically the cognitive and emotional personality that separates from the dying body and stays fully self-aware. According to the World History Encyclopedia's analysis of Mesopotamian funerary texts, this wasn't a vague spiritual concept. It was a defined structural component of human identity. The Atemu carried your memories, your voice, your recognizable self. Instead of fading into nothingness, that self crosses a hard boundary into Kur, later called Irkalla. The ancient sources describe this place as the land of no return, or the great city, a dusty realm of darkness ruled entirely by Ereshkigal, the sister and counterpart to Inanna. Entry happens through the palace Ganza, which is exactly where those 7 guarded gates are stationed. The crossing isn't instantaneous either. The texts treat it as a deliberate migration, a structured departure rather than a sudden drop. Once the Atemu gets past them, the awareness doesn't switch off. It just gets stripped down to its bare essentials. The texts even note that these entities could move freely between worlds, crossing back into the living realm to visit families or demand proper burial rites, which is why the word ghost actually traces back to this exact Mesopotamian framework. You get a continued existence, just heavily diminished and completely detached from the flesh. Why would a culture with no MRI, no EEG, no science of the brain at all, independently insist that the aware part of you outlasts the body? Now, let's be clear about what we're looking at. This remains an ancient cosmological claim, not a clinical finding. The Sumerians didn't have electrodes, scanning machines, or any concept of neural activity. They constructed this framework from ritual observation, literary tradition, and a cultural insistence on mapping the unknown, maintaining that Atemu required constant ritual support from the living, which proves how seriously they took the persistence of consciousness. They didn't treat death as a hard stop. They treated it as a relocation. They tracked the soul's journey with the same precision they used for trade routes and flood cycles. That said, the sheer specificity of the claim is what makes it impossible to ignore. A civilization working with copper chisels and clay accounting tablets still insisted that identity survives physical collapse. They mapped a staged transition of awareness centuries before medicine could even locate the brain. And that persistent idea sits right at the center of the modern conversation, because somewhere along the timeline, scientists finally built the tools to listen. For 4,000 years, that was the tablet's word against silence. Poetry, not proof. Then, in a hospital, a team left an EEG running on a dying brain they couldn't save. They expected a flat, fading line. For 30 seconds, they got the opposite. So what does a brain actually do in the moments after the heart stops? 30 seconds that shouldn't have happened. It turns out the brain doesn't go quietly, it spikes. In 2013, a research team at the University of Michigan, led by Dr. James Bortjigan, stumbled onto this phenomenon entirely by accident. They were recording neural activity in rats undergoing induced cardiac arrest, fully expecting the electrical readings to taper off into a flat line. Instead, the monitoring equipment caught a signal that made the researchers double-check their calibration. They first dismissed it as an equipment error, then repeated the trials across multiple subjects to confirm the reading. According to their peer-reviewed study published in the Proceedings of the National Academy of Sciences, the dying cortex produced a transient surge of synchronous gamma oscillations within the first 30 seconds after the heart stopped. This massive electrical burst occurred right before the EEG finally registered as completely isoelectric. Gamma waves represent the fastest rhythm the brain can generate, which translates to the neural machinery of high-level awareness. It is the exact frequency that fires when a complex idea clicks into place or when you instantly recognize a familiar face in a crowded room. your neurons lock into tight, rapid synchronization to bind different sensory inputs into a single, coherent thought. That is gamma. And in these cardiac arrest subjects, the gamma surge didn't just appear randomly. Its coherence actually exceeded the animal's normal waking baseline. The signal was cleaner, sharper, and more tightly synchronized than when they were fully awake and navigating their environment. Now, does a sudden spike in gamma activity prove consciousness is still running? Not automatically. Gamma correlates with conscious processing and memory binding, but electrical correlation does not equal subjective experience. The dying tissue could simply be releasing stored chemical energy, or neural networks could be firing their final reserves as oxygen cuts off. We cannot attach a first-person experience to an oscilloscope reading, yet the pattern remains too structured to dismiss as cellular decay. For the first time in recorded history, a scientific instrument watched the exact window the Sumerians called the Giddim moment and captured highly organized activity instead of an immediate shutdown. The machinery didn't collapse into chaos, it peaked. That single measurement forces us to rethink the exact second life ends. If the brain's most consciousness-linked rhythm surges the instant the heart stops, is that the mind switching off or flaring one last time? But this was rats. Rats aren't people, and one species proves nothing about what you would feel. So the obvious challenge is the one that decides everything. Does the same thing happen in a dying human brain? When it happened in a human, yes it does. And the reading from a dying human brain was nearly identical to what the lab saw in rodents. In 2023, Dr. James Bourgegan and his colleagues tracked continuous EEG recordings from 4 comatose patients who had their life support withdrawn. Getting this data is notoriously difficult because hospitals rarely keep electrodes attached once a patient is declared terminally ill, but this team secured the necessary monitoring equipment ahead of time. According to their PNAS paper, DOI 10.1073/PNAS.22162681120, 2 of those 4 brains produced a rapid and marked surge of gamma power within 30 seconds of ventilator removal. The spike lasted up to 2 minutes before the signal finally flattened. The research team had to calibrate every amplifier and shield the equipment from hospital interference just to make sure the signal was real. This wasn't a glitch in the monitoring equipment, it was a reproducible physiological event. That gamma surge wasn't random noise spreading across the cortex, it was highly organized. The researchers found increased interhemispheric connectivity, which is a clinical way of saying the left and right hemispheres stopped operating independently and started firing in perfect lockstep. Activity in one brain region directly predicted the pattern in another. The dying network wasn't collapsing into chaos, it was tightening its grip. That window of 30 seconds to 2 minutes after the ventilators were pulled is the actual time frame the title gestures toward. It is not 7 minutes, it is closer to 2. But within those brief seconds, the electrical signature of high-level awareness flared brighter than it had while the patients were still being artificially sustained. Gamma waves are the exact frequency your brain uses to bind disparate memories into a single coherent scene. So this surge suggests the dying mind wasn't drifting. It was rapidly assembling information. The brain wasn't shutting down. It was broadcasting. Imagine trying to watch a high-definition movie while the projector is slowly being unplugged. Instead of flickering out, the image suddenly becomes impossibly sharp for a few final seconds. That is what the EEG traces actually look like. The electrical readings align strangely well with what survivors actually report. Dr. Sam Pania at NYU Grossman School of Medicine led the AWARE-2 study, tracking 567 cardiac arrest patients across 25 hospitals in 3 countries. The research team trained nurses and physicians to ask specific questions immediately after resuscitation, minimizing the chance that hospital staff would accidentally plant false memories. About 1 in 5 of those patients who were successfully revived, described a lucid, recalled experience of death. They weren't reporting vague hallucinations or fragmented dreams. They described clear, structured awareness during the exact window when clinical death was confirmed. Patients noted observing the medical team, feeling detached from pain, and experiencing a coherent sequence of events that matched the timeline of their resuscitation. The consistency across different hospitals and cultures is what keeps researchers up at night. Some even accurately described medical procedures they couldn't have witnessed with their physical eyes, which forces clinicians to take the testimony seriously. Nearly 1 in 5 people who came back described a lucid experience of dying. So why do almost none of them remember it as simply nothing? You start seeing the convergence. Rat cortex, dying human cortex, survivor testimony. All 3 point to a structured dying process rather than an instant blackout. The Sumerians mapped a staged passage where identity peels away layer by layer. Modern electrodes catch a coordinated electrical flare in the exact same window. The tablet is poetry, but the data follows a similar shape. We still don't know whether that gamma surge is the brain broadcasting a final conscious moment or simply firing its last reserves as oxygen vanishes. But the pattern is too consistent to write off as random decay. The machinery of awareness doesn't just switch off, it completes its final cycle. At this point, it's tempting to declare victory. Ancient tablet, modern data, case closed. The Sumerians were right, but that's exactly where honest science slams on the brakes. Because other scientists looked at the same numbers and said, "You've read this backwards." And their objection is much harder to dismiss than you'd hope. The objection that keeps this honest. The objection cuts right to the core of the interpretation. When Dr. Bruce Grayson, Dr. Evan Kelly, and Dr. Michael Dunzerteth reviewed the initial rodent data, they pointed out massive statistical mismatch that completely changes how we read the findings. According to their 2013 reply, published in PNAS DOIE 10.1073/PNAS.1316937110, every single rat in the original study produced that exact gamma surge pattern. Yet only 10 to 20% of human cardiac arrest survivors report a near-death experience. If the electrical spike were the direct biological trigger for consciousness at death, the correlation should be universal across both species. It simply isn't. That gap forces us to treat the reading as a physiological possibility rather than a guaranteed event. They also highlighted a crucial technical detail that gets completely lost in media coverage. The post-arrest electrical activity registers at a tiny fraction of the brain's normal pre-arrest neuroelectric power. Neuroelectric power is just the raw electrical energy the cortex generates while processing information. When you measure it properly, the dying surge isn't actually hyper-aroused. It represents a highly coordinated but significantly weaker signal fading into silence. Gamma waves consistently track with moments of focused attention and memory binding, but tracking something is never the same as causing it. The surge correlates with the neurological architecture of awareness, which doesn't automatically prove subjective experience is still running. It might just be the system running its final diagnostic check before the main power cuts. The researchers noted that hospital monitors often pick up minor electrical fluctuations from surrounding equipment, which means any claim about a dying brain needs rigorous isolation protocols. When those protocols are applied, the signal shrinks considerably. The distinction matters because popular accounts frequently frame the dying brain as entering a state of extreme excitement. The raw voltage data directly contradicts that framing. Strip away every overstatement, and one fact won't go away. Why has every era of humans described dying as going somewhere, never as simply stopping? This is where the honest resolution lives. The ancient tablet never predicted modern neuroscience, and an EEG trace never proves the existence of a detaching soul. Both remain firmly within their own domains of literary tradition and clinical measurement. What actually links them is the shape of the description itself. A civilization writing on wet clay 4 millennia ago and a modern intensive care unit tracking voltage spikes both describe dying as a structured passage with persistent awareness, not an instant void. The Sumerians mapped a staged departure where identity peels away layer by layer. The electrodes catch a coordinated final cycle where neural networks lock into tight synchronization. The survivors describe lucid sequences that match the clinical timeline. We don't have an answer yet, but the convergence itself is the genuine anomaly. This pattern of describing death as a journey rather than a termination appears across virtually every ancient culture that kept written records. The specificity of the Sumerian gates mirrors the staged neurological shutdown we now observe in modern monitors. Scientists and ancient priests are operating with completely different toolkits, yet both arrived at the same structural intuition. The machinery doesn't collapse into random noise. It follows a recognizable arc. You stand at the edge of that exact boundary every day, wondering what happens when the lights finally go out. The data refuses to give a simple yes or no, so the tablet doesn't hand us a stopwatch on the afterlife, and the EEG doesn't hand us a soul. What they hand us together is stranger, a 4,000-year-old agreement about what those final moments are like. Outro. The Sumerian tablet didn't give us 7 minutes. It gave us 7 gates, and a self that stays awake when the body stops. And then, 4,000 years later, a dying brain fired for 30 seconds like it was trying to prove the point. So here's what I want to know. Do you think that Gamma Surge is the mind's last spark? Or the doorway the Sumerians carved into clay? And would you want to know what those final seconds feel like? Drop your thoughts below, because this story isn't over.